In this video, I'll be talking about some dinosaurs and Pangaea, the ancient supercontinent that once existed on the Earth. Specifically, I'm going to be talking about dinosaur biogeography with a focus on a few species of theropod dinosaurs. Theropod dinosaurs walked on their hind legs and had very small arms, and they became large meat eaters. The best known theropod dinosaur is probably Tyrannosaurus rex. It was one of the largest theropods. Fossils of this fearsome creature have been found in what are called Upper Cretaceous rocks of North America. Other similar creatures were found in Asia. T-Rex was actually a latecomer as far as dinosaurs were concerned, and there were many other theropod dinosaurs that existed before and even during the time that Tyrannosaurus rex was walking the Earth. There were some Jurassic theropods, and the Jurassic rocks are older than the Cretaceous rocks in which Tyrannosaurus were found. One example is a creature called Ceratosaurus that was found in Jurassic rocks of North America and was also found in some rocks in South America and Europe. Allosaurus is another Jurassic dinosaur. The best known example of Allosaurus was Big Al, which is a 95% complete, partially articulated skeleton found in Wyoming, USA in 1991. Allosaurus fossils have also been found in North America and Europe. Then there are many other Cretaceous theropods. One example is Carcharodontosaurus, which was similar but had teeth which resembled shark's teeth, hence its name shark-tooth lizard. It was found in North African mid-Cretaceous rocks. Theropod fossils have also been found in South America. For example, Abelisaurus and Carnotaurus. Abelisaurus is actually only known from a skull, while Carnotaurus is better known as an almost complete skeleton has been found. Both of these creatures are found in South America in Argentina, and some similar creatures found in nearby Brazil. Carnotaurus was an interesting dinosaur with short horns on its head and very short arms. Again, these creatures are found in Upper Cretaceous rocks. The various theropod dinosaurs are grouped together into families and superfamilies. For example, Allosaurus and Carcharodontosaurus belong to the Allosauridae family, also known as Allosauroid. The tyrannosaurs and similar creatures belong to the Tyrannosauridae, otherwise known as the Tyrannosaurids. And you have Abelisaurus and Carnotaurus are grouped together into the Abelisauridae, otherwise known as Abelisaurids. The interesting thing about these creatures is where they are found in the rocks. A number of species of the Abelisaurid family have been found in South America, but also in North Africa and Madagascar, and also in India. These places are now separated by thousands of miles of ocean. The distance from Argentina to India is actually nearly 16,000 kilometers or 10,000 miles. The question is, how did these species, which seem to be related to each other, get to be living on three different continents? Well, the answer to that question comes when we look at Pangaea itself. If we look at a map of Pangaea, we will see that these continents were once joined together as part of Gondwana, also known as southern Pangaea. Pangaea, as I mentioned earlier, was a supercontinent that existed a long time ago, at the time during which Permian rocks were being deposited on the Earth, and it started breaking up as Jurassic rocks were being laid down and the dinosaurs were becoming more common. And we can see here how the dinosaurs could very easily have spread across the southern continent of Gondwana, which explains the distribution we see today. Now, how do we fit all this into creationist thinking? Well, I would like to suggest that we can think of a model which I'm calling the post-flood diversification model, which could explain how these various species of abelisaurids got to where they are. It seems likely that all these species of abelisaurids were descended from one common ancestor that could have spread out across Gondwana before it started to split up. As Gondwana broke up and rising and falling sea levels caused by seafloor spreading, there would have been regional flooding and the deposition of the rocks in which these fossils were found, first in Triassic rocks, then Jurassic, and then Cretaceous. So the Cretaceous abelisaurids all descended from a common ancestor which spread out across Gondwana before it started to split up. And it's these rising and falling sea levels as a result of seafloor spreading which would have resulted in regional flooding and deposition of the rocks in which these fossils were found. So in this post-flood diversification model, I believe that we can explain all of the evidence that is published in the literature today on dinosaur biogeography. The starting point would be that all theropods and other dinosaurs were descended from a few dozen kinds which repopulated the earth after the end of the flood of Noah. So the earliest post-flood dinosaurs left the ark at about the time the Triassic rocks were being laid down on the newly exposed supercontinent of Pangaea. And as they spread around, occupying new lands, they would have multiplied and diversified into the species which we find today in Jurassic and Cretaceous rocks. Now, this post-flood diversification model could be extended to explain the biogeography of all the various fossil creatures we find in Cretaceous and Jurassic and Triassic rocks. And this is what some of us will hope to do as time passes. So keep your eyes open for various postings and reports on this subject. Thank you for watching this video.